We are going to get our next panel started. We are fortunate to have a one-on-one discussion between Sandeep Nailwal, the co-founder of Polygon, and Juan Benet, the co-founder of Protocol Labs. Please welcome Sandeep and Juan.
You gotta let them know when you're ready to go up, otherwise they're not ready.
Hello, hello again. Hello, hello. Hello again. Guys, so I have with me dear friend Juan, founder of Protocol Labs, as you know, Filecoin. And I'm a big fan of his work. Like, when I was just getting started, he was a legend, at that time itself. So it's always great to, have conversations with him and get his perspective on various things. So this is the, this conversation is more focused around AI. And we don't even have a set agenda for this. Like, we would love to take, audience questions on this. Maybe we can start with audience questions if you guys have anybody has any specific question, or we can start with general intro. Anybody?
Cool, there was some question back there. And by the way, honor to be here. Always very excited to talk about lots of things together. We want to make sure to talk about the things that are top of mind for you. Both of us have thought a lot about different things in AI and decentralized AI and the potential, but we want to make the conversation really valuable and interesting to you. So let's get some questions out. So I think there was a question back there. Can't hear you, so you gotta be louder. So the question is, our work in compute over data, how much overlap is there with decentralized AI? Yeah, so running an AI model is a type of computation. So if you're structuring a way to do all kinds of computation, an AI model and running an AI model is like one class of that kind of computation. And in fact, most of the compute over data networks that are being built right now are going after AI models because that's what's extremely valuable and hot right now. So yeah, it's like perfect overlap. Yeah. More questions? Yeah, back here. Can we keep the questions AI focused? Because that way, is there like an AI side to that? So you're saying does the model not know what it's computing? So a model to be able to run and operate on something has to compute on a set of data that you're going to give it. So as it's computing on it, it's going to find out what it's doing. The thing that can't know, right, so what you're getting at is the hardware itself or the VM that's running the model doesn't know. And so I guess what you're saying is like, hey, could we create a privacy-oriented AI cloud where you can have models that are fully private, that where you can develop either the model or the data that you're going to compute on with full privacy. And there are two techniques to do this, like zero knowledge and fully homomorphic encryption. Both techniques can work. They have different trade-offs. There's a project around zkML that you can check out. And what I'm personally really excited about is FHE. I think there are FHE ML ways, structures. Zama is a company that's going after this. So both of those are like pretty interesting. I don't know if you want to add anything.
Yeah. Like Zama is one company. Inco is another company who's working on FHE. And like only problem with FHE and zero knowledge, cryptography on that is like right now the efficiency wise, it's like extremely compute intensive, and AI itself is compute intensive, and it's super hard right now. Like to have like what your original question was, that how can you have like some sort of this, what you are saying is private computation over a, let's say server, where server itself doesn't know what it's going to compute and things like that. I think one easier way in the earlier days or like in the near future that people are going to use it is people are going to use TEs a lot, like trusted environments, where you actually put, let's say, a base model, right? Like, especially, let's say, some of these design patterns that, like, for example, Sentient team is also exploring, that where you put a base model into a TE And then after that, you train the model inside the TE. So nobody knows the new weights of the model, right? So the new model is completely getting trained inside the TE, and the inferences are also being, kind of, thrown after, like the queries are being thrown after the TE model. So that is one near future model where people are going to do that a lot. But in the long run, like, I really loved what Jeff Bezos recently said, that, these models are more than inventions, they are discoveries, right? So, like, we are also thinking of multiple ways where you can train, like, but again, this is like a slightly different, like, model loyalty, where you want, let's say there is a community-owned model, and you want that model to be loyal to the community. That means unless the community has permissioned the model to, let's say, provide inferences or take training data, it doesn't take it, right? So there are multiple ways like FHE and ZK and for doing that. But other ways, what if like somebody comes up with a interesting training technique where all the neural nodes of the model itself are loyal to that particular thing. So that is an interesting way, like what Sentient team is working towards, and I think that's a very interesting area to explore.
Yeah, I personally think that the highest value thing that can come out of crypto and AI together is a much stronger governance framework on top of running AI models. So this is where you can figure out the provenance of the models themselves, what data they were trained on, what are they likely to do, and where you can add controls over what the inference requests could be. If we can do that well, then we can build pretty scalable ways of having much safer models out in the wild. Because when we're talking about, we're at an event called Decentralized, I think it's Decentralized AGI, right?
Yeah.
Like, first off, like, man, I can't think of few ways of making the AGI problem more scary than making it decentralized. Like, that just like greatly amplifies all of the things that could possibly go wrong. And so it's like, okay, well, what is the bright, optimistic case here of like, how do we orient this towards like good outcomes? It's like, well, okay, great. We have this rule machine, this like governance structure machine. Can we use it to then orient the models to achieve good outcomes? And so that looks like figuring out what data it was trained on, what algorithms are being run, whether the alignment, the alignment type protocols that you're running on top are actually working. You can trace the individual inference. You can inspect the outputs. If we can do that really well, then maybe we have something to offer to actually make the problem better. But otherwise, we're just going to make things look dramatically worse. Yeah. And so be careful. And to spell it out, because I see some people that are like laughing, like, oh yeah, shit, that's potentially really bad. But I also see some people like, what do you mean? That's kind of, how could it possibly be worse? Well, look, when you have an extremely capable model that you can ask to do, like AGI, to define it, it means that the model should be able to do anything that a human can do that's knowledge work. It should be able to think through and reason anything that a human can do. Now imagine you take a human as capable, the smartest person that you can think of, virtualize them in the computer, give them unlimited resources, and then just let them unfettered on the internet. That is potentially really good or potentially really bad. It has many ways where that could produce very bad outcomes for the world. And so if we create lots of compute clusters around the world that we have zero oversight into, we like decentralize the AGI capable compute clusters, and then we let thousands of people to millions of people try whatever they want on them. That's a great way of getting disasters to happen. That's like a super, super easy way of just causing all kinds of havoc. So now how can we use our truth machines, our like verifiable computing machines, to instead aim away from those really bad outcomes and go towards like the really good outcomes? I think provenance is a really good way. I think control over the actual models is potentially a good way. But other than that, I don't see that there's that much.
No, I totally agree with you that, when, like for the last whole 1 year, like I've seen so many pitches from the AI, startups, which are like, many of them are simply crypto token startups, and they're just trying to sprinkle some AI on it because there's hype. But, many of them also come to you and, want to have this decentralized like model, like, just because we come from the background of Ethereum, where there is one VM which is run by multiple parties in the environment, and everybody is trying to many people are trying to think that, okay, we'll have a decentralized environment where this model is running like in some sort of coordinated way. And one is you were saying that philosophically it can be super bad for the world. The other way is like I'm simply thinking, because we saw this world when from 2017 when you're trying to scale the blockchains, we can't do simple value transfers scalably in decentralized networks yet. Nobody has figured out.
We're finally getting there.
Yeah, and the only way now people are getting that with layer 2s and all that is doing it in a trustless way. That's not decentralized, and that's my whole point. The trustless phenomena is actually much bigger than the decentralized phenomena. If you see the ZK rollups, optimistic rollups and all that, what they are doing, there is a single sequencer, and wherever you need decentralized okay, so we started with the background of BTC, right? This whole industry started with the background of BTC, and it was very important to have decentralized networks so that you can have 3 key properties. One is trustless compute, then self-ownership, and then third one is censorship resistance, right? But now with this ZK, especially ZK, you can actually achieve, and an optimistic rollup also, you can actually achieve the first 2, trustless compute and self-ownership, self-custody of your assets, without decentralization. So you then I started thinking that actually it was never about decentralization that much, except BTC. It was
and
about.
that's what a lot of us meant by decentralization. The verifiability piece is the most important part. It's you want to make sure that the computation itself is verifiable against what you expected the computation to be.
Exactly.
Right. So that you're getting the right outputs. I sometimes talk about it in terms of read, write, verify. So that's the benefit that you get out of decentralization is either availability of more nodes being online, but really verifiability that the thing is going to do what you expect it to do.
Yeah. So the interesting thing I wanted to bring back, because I went into that different arc of history of this decentralization versus trustlessness, is that in this context when we say decentralized AGI, what we are saying is decentralized in terms of
Verifiable.
Who kind of trains it. Because right now, let's say you have open AIs of the world who are training it, and then who controls it, these 2 parts. If you are able to decentralize these 2 parts and separate these 2 parts from the actual execution of the model itself, what is happening with the ZK and all that, right? So you have kind of solved scalability trilemma in some form where you just, in some form, I'm just saying that, where you removed security and decentralization from the scale part of it. You compute at an extremely fast pace, and you are in the background, that there's a proof that's going to come and it's going to be verified on the main layer. So with the AI also, the attempt that we are trying to do, let's say, and Sentient team is trying to do, is that decentralize the training, verifiable, as you said, verifiable training. If you have a model M1 and there is a data D1, and if you train this model with this data D1, what comes out is M2. Can you prove that what comes is M2? Yep. And the second thing, and these are the 2 scientific problems that we are focusing on, is that one is the model, the provenance, training provenance. Second is model loyalty. What if you could create a model which is think of it like a Navy SEAL soldier. Let's say United States trains it. Even if somebody else captures the soldier and they try to get the secrets out of him, he will not give. Can we do that same with the model brain? It's like neurons itself, right? How can you train the model in a way where the model never responds? Even if you download it and you're running it on your computer, you ask him a reference, ask the model a reference, it doesn't respond to you unless you have the explicit permission of the network.
And I think that there's going to be easy ways to, or performant ways of achieving that with the current training methods, but the real solution to that long term is verifiable FHE. If you have verifiable FHE, then you can build a large scale model that parties observing the data cannot understand what the computation actually is. But that, of course, has the problem of massive orders of magnitude of slowdown.
FHE is basically at least 3 to 5 years of work we need on FHE, right? For
right, but the good news here is exponentials get really fast over time. So you just wait a few more years until these techniques can
fully
work.
agreed. We have one person who has a question.
Yep.
You mean specific to the AI or in blockchains in general? AI, okay, OPML versus ZKML. Like, that's the question.
Look, my sense for, you can use optimistic approaches to run in high performance for things where you want to just run a lot of computation. So for example, Gen AI use cases seem like a decent use for this. Well, maybe. So what I would push to harder verifiability settings is areas where you really care about the outputs being correct. Like if you're trying to get like a few images, you're trying to sample a large space. The acceptance criteria is actually quite broad. Lots of different data points are good enough. But if you're trying to decide like whether to, you're sick with something, you're trying to get a diagnosis and a recommendation for treatment, like that needs to be correct, right? Or if you're gonna let a model pilot a vehicle of some kind, that should be correct, right? And so when correctness really matters, that's when you want to go all the way to strong verifiability properties.
Yeah.
I think both ZK and verifiable FHE are good enough technologies, and they'll continue to get better, that you can do some scoped problems in them, and with time, all problems eventually. It just is a matter of like when you want to run it. If you want to run it tomorrow, you cannot use verifiable FHE. It's just way too slow. But if you want to run it 10 years from now, yes.
Yeah, and with ZK also, like, what people are working on is, like, originally people wanted to, like, fully verify the full compute of the model. Now people are saying that can you just verify like one or few branches into the execution of a query and things like that. But for me, like this provenance of, like here, the provenance is actually that X model that was committed, that this model is providing the inference. That's the exact model which is providing the inference, right? And for me, like I somehow fail to see, and if anybody has like more use cases which can actually acquire a lot of like, which can accrue a lot of business value, let me know also. But otherwise,
let me push back on that. So I think it is very critical that if I'm gonna start trusting an AI agent to do things on my behalf, I want to know that that's correct, and that as these things get smarter and smarter and smarter, they aren't getting misaligned from my intention and starting to do something other than what I'm asking.
Yeah, yeah, but isn't that like, it's actually more of a question of correctness, as you are saying, than of provenance? Like, let's say I'm using...
Yeah. So it's a provenance so that you can try and approximate correctness, but correctness is what we care about.
Yeah. Like, but for simple provenance, I was seeing like, I only see this, maybe DeFi security use cases for provenance, and probably like if you want to use like AI models for governance, then you want to be like, okay, this is the model that governance approved, and this is the model which is talking about. But apart from these two core like use cases, I've not seen like maybe deepfake, like you want to on-chain.
Well, yeah. You may also want to trace who is training models to do what, who is invoking models to do what kind of thing. You may want to log that over time, and that becomes a really valuable kind of community-oriented thing. I think you've had a question for a while.
Yeah, you had a question, so go ahead.
Yeah, so the question is, can you use the decentralized compute platforms to do both training and inference, or just one of those? Both. You can model both structures in this decentralized network. It's just that training is dramatically more expensive than inference, so that's a harder problem. But you can do it with both. And there are networks, compute over data networks, that are trying to do both.
Who just arrived here? Like, this is Daniel Lubarov, one of the co-founders at Polygon, like, and in my mind, like the best of the best brains in the ZK in crypto. Like Daniel, like thanks for coming. But yeah, go ahead. You were saying? Did you catch the question?
So what was the first part of the question? Oh, so you're asking like what are the kinds of risks that come from crypto? So the question is like, hey, can I be more concrete? Can we be more concrete on like what are the risks that crypto introduces to the AI question because a lot of people have been writing a lot about the risks that come from smarter and smarter models. What happens when you enable them to like have access to blockchains? Well, think about it this way. If you have like cryptocurrency is a resource that you can spend for compute, right? So you can create an agent that has an account on a blockchain that can pay for its own resources and then can start doing other things to try and cause its own balance to increase. Like that's creating not just like an artificial intelligence, that's creating an artificial life form that now has a way of growing and potentially replicating and so on, right? Like that gets like really hairy really fast. You could have LLMs, probably, I wonder if somebody's doing this right now, this would be really bad. Like you could probably have LLMs today be like trying to optimize for how do they increase the amount of money in a wallet with just an email address, trying to spam all kinds of people to do who knows what. Yeah. Like that's like extremely dangerous type of behavior. This is how you get like rogue optimizers.
I know one person who is doing it, but for DeFi strategies, not the.
No, like this is like very dangerous stuff. Like my sense is, today we have the tech to like do some pretty bad things, and it's kind of like we're kind of on borrowed time in terms of the people that know a lot about the models and the people that know a lot about crypto. The intersection has been really small. Events like this are bringing that intersection together. So right here, we're like increasing the risk. So hopefully, all of you are aiming towards good outcomes and don't do like really bad things accidentally. So yeah, focus on how do you produce really good use cases for these models, and be careful about what models you deploy and how you give them access to random capabilities, like email, like optimizing for a certain blockchain, like for a certain amount of like money on a wallet, like that's a recipe for something really bad going on. Yeah. Like definitely do not try genetic algorithms with this kind of stuff. Like, please don't do that. Anyway.
That's why like I said that I as crypto community overall, we all should optimize for, or we should all put more resources on, making sure that these powerful AI models, which assumingly in this open world can be trained by the communities and will be more available, because all the models that are made available open source by these large companies, like the actual fine-tuned models they use for their own stuff, right? They will never put it out because there's like competitive moat in the longer run. So in my mind, like community trained models over the long enough time are going to be the most powerful. And so the problem that I want to put my focus on, that the most powerful community trained models should be not like decentralized, as in like they are running in a decentralized compute environment, but they are controlled by the community. Like if community says, like, let's say this kind of inference is toxic, or this kind of queries are toxic, do not respond to this.
Yep.
And the model is loyal.
Yeah, exactly. And that's what I think, like good, the provenance of the not just the model, but the actual invocations, like the inference that you're requesting, is really key. And I think good governance frameworks for this could be really valuable. An optimistic type of project, like try doing it today. Like grab a community that cares about having some AI assistance, get a foundation model, and like create some loose structure around invoking its operations, but have like a little bit of a check as to whether or not that inference request is broadly aligned with the goals of the community. And this would be like a good, interesting test case where like you'll be forced to like actually implement something that is useful for somebody, for some group, and you'll grapple with how hard it is to answer that question, whether the prompt is going to be in the best interest of the community or not. And like that's where a lot of these questions hinge on. If we can figure out good ways of doing this, we'll be in good outcome. I think we're wrapping up, so maybe last question.
Okay. Okay.
So the question is, what do we think about multi-party computation as another approach? Yeah, we would probably classify it just like with ZK and FHE. It's another technique that gives you the same set of outputs. You can use optimistic computation, you can use MPC, you can use ZK, you can use FHE to broadly compute whatever program you want, and it has different characteristics in terms of the topology of the network, the the verifiability that you get out of it, the privacy that you get out of it, and so on.
And you end up, like, you don't really fully solve the centralization problem because those MPC parties can simply get in a Telegram group and, do what they want. So
I think he really wanted to ask a question.
yes, please
That's what he
go
said,
ahead. Please go ahead.
Yeah. What do we think about whether more of the value will come from small models versus large models? Well, our brain is pretty large, and in about 1 million years, we kind of took over the planet. And so large models are going to be really where the extremely valuable outcomes will be.
Yeah.
So sure, small models will be able to do all kinds of small tasks in the meantime and be very economically significant. But in terms of like a really species or civilization scale improvement, large models is where it's at.
Yeah, I have a different, obviously large language models, going to be really powerful, but also like what Pramod, sometimes from Sentient, he always mentions that, all of these models provide some level of intelligence, but various different kind of models, some will be very good at maths, some would be very good at, let's say, medical stuff, these are all human brains, and a combination of them, with better routing and coordination of them, can actually convert this I, intelligence, into GI, general intelligence. So I think in that context, I can see in future some kind of combination of few models together, where some of them are small language models, which are doing some great work in terms of what they can do, and there are combination of LLMs and mathematical models and whatever, and they are working together to do something. Yep.
All right. Well, thank you very much.
Yeah.
And do good things, avoid bad things.
Thanks, everyone. Thank you.